So, this time, we will get the final dilution. Focus buddy. Final dilution. So, the final dilution is, the formula of final dilution is that you must multiply each dilution made. So, we have the first dilution made, so it has no other dilution made, so it's constant. Common number, 0.1. Exponential number is 10 over negative 10 with exponent of negative 1. So, how do we get the stock solution? So, to be able to get the concentration rather, we will multiply the stock solution concentration to the final dilution. So, how do we get that? It's that 0.1 is our final dilution and multiply by 250 milligram or ml. So the answer is 25 milligram or ml of concentration. That's it. The concentration is 25 milligram or ml. And let's proceed. Stir it well so that it will mix together very well. Okay, we will get 1 tablespoon from our less concentrated stock solution to our diluent. As you can see, compare guys, compare. Look at the stock solution. Look at the stock solution, guys. Oh, as you can see, the stock solution is much darker than the less concentrated and the lesser concentrated. So, let's compute. Dilution made is, at its constant, 10 exponent of negative 1, and common number is 0.1. Why? Because, as I said, serial dilution is a stepwise process that the dilution factor is has constant measures. So, I get 1 ml from the stock solution, I get 1 ml from this, and then I put 1 ml for this solution. So, okay, that's why I'm putting 10 has an exponent of negative 1 or 0.1. Okay, guys? So, to get the final dilution, we must multiply each dilution made. So, negative 1 times negative 1 times multiplied by negative 1 is 10 over with exponent of negative 2. That's it. Oh, I am wrong. So, I will put 0.01. That's the common number. And then, to be able to find its concentration, you must follow the formula. Final dilution multiplied by the stock solution concentration. So, 0.01 multiplied by 250 ml or milligram is 2.5 ml or milligram. That is our stock solution. And so on and so forth. So, we'll go faster. G. Negative 1 because it's constant. Negative 1. 10 with exponent of 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 negative 1. 10 negative 1. Okay? So, as you can see, I put 10 with a negative 1 exponent because to the power of negative 1, 10 with to the power of negative 1 because it's constant stepwise dilution serial dilution. Sit. Okay? Sit. And my diluent is always 9 ml. every cup has 9 ml to make a solution of 10 ml because I put 1 ml from the stock solution. Okay? So 1 ml plus 9 ml equals 10 ml. G. So we must get the final dilution. But we must answer this, okay? -1 times 10 to the power of -1 multiplied by 10 to the power of -2 is 10 to the power of -3. And so on and so forth. So I must add 1 because it always no now. It's constant. Remember? It's constant. Why will be hard to myself? It's constant. So let's go easy. Life is easy. So on and so forth. 0, 1, 0.00, 1, 0.00. So that's it. Thank you for the waiting. And then we must get our concentration. Right? So final dilution multiplied by the stock solution the concentration the stock solution. Final dilution multiplied by stock solution, that's the answer. So the next is 10 to the power of -3 multiplied by 250 milligram or ml. So the answer is 0.25 milligram or milliliter. Then and so on and so forth. So 0. As you can see, it has a constant ratio. So why would we be hard to ourselves? It has a constant ratio. Apply geometric formula or geometric sequence. So 0.25 G and so on and so forth. Why would you be hard to yourself? There's an easy way, grab it. Okay? So, here is the final table. You can see there is a geometric ratio. There's a ratio. It is a geometric sequence because it has a constant ratio that is negative 10 to the power of -1. That's it. Okay? So I'll explain more further. 10 to the power of -1 times 10 to the power of -1 is equals to 10 to the power of -2. 10 to the power of -2 times 10 to the power of -1 is 10 to the power of -3. And so on, so forth. 10 to the power of -9 times 10 to the power of -1 is 10 to the power of -10. That's it, guys. Bye-bye, guys. I hope you enjoy and you have learned many things from me. And that is our serial dilution explanation.